Okay, welcome pre-cal students to the homework help video, page 618, numbers 25 through 49. Let's go ahead and get started with the the homework help video today. All right, number 25. Number 25, sorry about that. Number 25 reads, the sun is 25 degrees above the horizon. Find the length of a shadow cast by a silo that is 50 feet tall. Now, students, understand, first of all, you're welcome to use their drawing, but once again, I want to encourage you to learn to draw your own drawings, because of the test or quiz, you're usually going to have to draw your own pictures. Okay, so here we go. The sun is 25 degrees above the horizon, and that would be like an angle of elevation. So here's the ground, okay, and then here's the angle of elevation up here to the sun. Okay, there's the sun right there, and we're going to put 25 degrees. Okay, now let's go ahead and put the silo right here. Okay, so there's our silo, and let's see what else it says. The sun is 25 degrees above the horizon. Find the length of a shadow is cast. Now, by a silo, it's 50 feet tall. Now, students, understand the silo here is 50 feet tall. Okay, that's fine. But listen, the sun is going to hit the silo this way, and the shadow is going to be formed on the ground right here. So when it says find the length of the shadow, that's what you're looking for, is the length of the shadow on the ground. Okay, so we're going to call this X, and this is really a simple problem. You should have no problem seeing the right angle here. Okay, so there's the right angle. I'm going to move this out of the way to get a little space. Okay, and so here we go. Here's your angle. We're dealing with opposite side 50 and the adjacent side X. So right away you realize that when you're dealing with opposite and adjacent, that you want to use the trig function tangent. So the tangent of 25 equals opposite over adjacent. Your denominator's X. So multiply both sides by X to get rid of your fraction. And then to get X by itself, you divide both sides by the tangent of 25. These cancel, and there's X. X is 50 over the tangent of 25. Okay, so with my calculator real quick, I'm going to type in 50 divided by tangent of 25 degrees, and I will get the correct answer of 107.2 feet. Okay, 107.2 feet. So there we go. That is the length of the shadow from here to here. Okay, moving on to number 27. From a point 50 feet in front of a church, the angles of elevation to the base of the steeple and the top of the steeple are 35 degrees and 47 degrees 40 minutes respectively. Okay, let's go ahead and get a picture of this, students. Here's the church right there. Here's the ground over here. And then let's go ahead and change colors. Here's the steeple right here. And it goes from here to here. Okay, there we go. Now, go ahead and put 90 degrees here. Go ahead and put a person standing here. And it says from a point 50 feet from the church. So I know the distance from here to here is 50. That's easy. Now, my first angle of elevation goes from here to here. Okay, and it says angle of elevation to, let's see, the angles of elevation to the base of the steeple would be 35 degrees. So this angle right here is going to be 35 degrees. Then it says the angle of elevation to the top of the steeple, so that would be from here to here. Is going to be, students, 47 degrees 40 minutes. So that means from the horizontal all the way to there is 47:40. So here's what I'm going to do. 47:40 minutes, as you understand, is 47 degrees find 40 over 60, which is really 4/6, which is really 47 2/3, which is really 47.6 repeating, okay? So the whole angle from here to here is 47.7 degrees if you round, okay? So what that means is this little angle right here is going to be 12.7 degrees, this little angle right here, because if you take 12.7, this angle here plus 35, this angle here, you'll get the whole angle, which is 47.7, okay? All right, so I've drawn the right triangles, I've labeled my known quantities. I'm not worried about labeling my unknown quantities yet. We can do that later. Okay, step B. Use a trig function to write an equation involving the unknown height of the steeple. I'm not going to worry about drawing an equation. I can go about that many different ways, but I'm going to go ahead and put this. I'm going to put the height of the steeple here is x from here to here, and I'm going to call the height of the church from here to here y. Now students, please understand you have two right triangles. You have a little right triangle right here, okay, in green, and then you have a big right triangle right here in red. Okay, now think about this. If I can find the height of this whole side from the big triangle and then find the height of this church in the little triangle, if I subtract those two, I'll have the length of my steeple, okay? So that's my goal. That's what I'm going to try to do. So let me quickly create a little space here, move this over to here, and let's draw our two triangles. Here's my little triangle right here, if I can get this thing to work. There we go. Here's my little triangle, and here's my bigger triangle, okay? Now my little triangle would look like this. My little triangle would have a y here, a 50 here, and 35 degrees here. So very quickly I'm going to find the length of y. I'm using opposite and adjacent, so I'm going to say the tangent of 35 equals opposite over adjacent, multiply both sides by 50. 50 tangent of 35 equals y. So with my calculator I'm typing in 50 tangent 35, and I'm going to get 35.01, so 35. So the length from here to here for y is 35. Now I'm going to find the entire length from here all the way down. We're going to call that z, I guess. So here's my big triangle. I know this is still a length of 50 right here. This is a right angle, and this whole angle here would be 47.7. So here we go, using tangent. Tangent of 47.7 equals opposite over adjacent. Multiply both sides by 50. 50 tangent 47.7 equals z. So with my calculator, very quickly, 50 tangent 47.7 would give me 54.94. So I'm going to put 55. So the whole length is 55. So students, think about this. If the whole length from here to here is 55, and this much from here to here is 35, if you subtract the whole length minus 35, you're left with 20, which would be the answer to the height of the steeple. Now, the book has 19.9, which is fine, so you could put 19.9 for an answer, or you're also welcome to put 20 for your answer if you want to, okay? All right, so moving on to number 29. Number 29. A ladder 20 feet long leads against the side of a house. Find the height from the top of the ladder to the ground if the angle of elevation is 80. This will be pretty simple, okay, students? Here's the ground. Here's the house. Here's the ladder. All right? Now, we should know, as long as the house is built properly, this will be a 90-degree angle right here. It's not leaning. The ladder is 20 feet long, so here's my ladder, 20 feet long. The angle of elevation, so here's the horizontal. Here's my line going up, so my angle of elevation is right here, and my angle of elevation is 80 degrees. They want us to simply find how high up the ladder is on the house, so the distance from here to here. So here we go. We're dealing with opposite and hypotenuse, so I'm going to say the sine of 80 equals opposite over hypotenuse, multiply both sides by 20. And then with my calculator, 20 sine of 80 would give me 19.69, so 19.7 feet. Pretty simple. Moving on to number 31. Now they do give you a picture here, which is fine. I encourage you to draw your own, but here we go. The sonar of a Navy cruiser detects a submarine that's 4,000 feet from the cruiser. So here's the line. I think green shows up a little better. Let's use green, okay? Okay, there's the line. And it's 4,000 feet away, okay? The angle between the water line and the submarine is 34 degrees. So here's the water line. And that angle is 34 degrees. Now, how deep is the submarine? Students, please listen carefully. Please, you are more than welcome to draw your right triangle like this. And find x. That will work. You would use sine because you have opposite and hypotenuse. You also could draw your right triangle down like this if you wanted to, and then over. And remember, your hypotenuse is 4,000 feet, okay? This is a right angle right here, so if this is 34 degrees right here, then this angle right here would have to be, what, 56, I believe? And then the depth from here to here is the same as the depth from here to here, so we call this x over here, okay? So you could say, oh, this is your adjacent side and your hypotenuse, so you could say cosine of 56 equals adjacent over hypotenuse, and that would work fine also. It's your decision. Now for me, I'm going to go ahead and use the other triangle because the problem is kind of set up really nicely that way. So I'm going to go over like this, draw my triangle down, and plus I already have my 34 degrees right here, so I'm all set. So how deep is the submarine? We're going to call that x. And so here we go. We're dealing with opposite and hypotenuse, so that would be sine. So the sine of 34 degrees equals opposite over hypotenuse. Multiply both sides by 4,000. 4,000 sine 34 degrees equals x. So with my calculator very quickly, 4,000 sine of 34 degrees, and you will get 2,236.77. So I'm going to round that to 2,236.8. So 2,236.8 feet is how deep the submarine is, okay? All right, moving on to number 33. All right, an amateur radio operator builds a tower, a 75-foot tower for an antenna. Let's see, find the angle of elevation to the top of the tower to a point in the ground 50 feet from the base. So here we go. Here's the ground. Here's the tower. Okay? And here's what we know, that the point from the ground to the tower is 50 feet. The height of the tower from here to here is 75. Now look what they want you to find. They want you to find the angle of elevation to the top of the tower at a point in the ground 50 feet. So angle of elevation means you need a horizontal line, which we have right here is our horizontal line. And then we need a line going upward. What says angle of elevation to the point up here? So I'm going to start here on the ground. And sorry about that, and draw a line. It's not too good, but hopefully you get the point. If we can get this down here, tie in a little bit. There we go. Okay, so you're looking for this angle right here. Remember, you always draw a horizontal line and then draw the line going upward to the point that you're referring to, which was the top of the tower. So we're looking for this angle right here. Well, students, I mean, it's really easy. We're dealing with, based on this angle here, we're dealing with adjacent and opposite. So tangent of x, TOA, opposite over adjacent. So I'm going to hit second. You're looking for an angle, so use second tangent 75 divided by 50, and you should get the correct answer of 56.3099. So I'm just going to put 56.3 degrees. Okay, pretty simple problem. All right, moving on to number 35. A cell telephone tower is 150 feet tall, is erected on top of a mountain that's 1,200 feet above sea level. What is the angle of depression from the top of the tower to a cell phone user who is 5 miles away and 400 feet above sea level? Okay, it's been pretty simple, not too bad. Let's see, here's our ground. We're going to call this the ground here. And then we're going to put a big long line here. And we're going to say this is sea level right here, okay? So from here to here, we're going to say is 1,200 feet, okay? And then the actual tower is 150 feet. Okay, there we go. Now, that's pretty simple, cut and dried students. Okay, it says you built the cell phone tower on a mountain that's 1,200 feet above sea level. So from here to here is 1,200 feet. Look at this like it's the mountain, 1,200 feet, and on top of the mountain is the tower, 150 feet tall. Now, sorry students, you're 5 miles away. Okay, you're 5 miles away, and let me see what it looks for. Let's go ahead and convert. We can't use feet and miles, so real quick, I'm going to change this 5 miles to 5 times 5,280. And instead of using 5 miles, we're going to use 26,400 feet. Okay, now we have everything in feet. Okay, now moving on. You're over here, and it says that you're using the phone 400 feet above sea level, so you're not really you're not really here. You're up about right here, 400 feet above sea level. Okay, so I'm going to go ahead and draw a line straight across here. Okay, so I hope I'm not losing you. Okay, and now I'm going to go ahead and draw my right triangle. Now let's see if we can do this. Okay, now watch carefully students. First of all, here's my right triangle I want to use. Okay, from here to here to here. There's my right triangle, and look what it says. Find the angle of depression. So depression means the angle from, I'm going to find this angle up here. Remember, angle of depression or elevation, you always first draw a horizontal line. So I'm going to draw my horizontal line, or at least try to. There's my horizontal line. And then from the horizontal line to the line I'm referring to is my angle. So I'm trying to find this angle here outside of the triangle. Now, to me, it makes total sense if I can find this angle here and then subtract from 90, I'll have this angle here because I have a right angle right here, okay? But don't lose sight of the fact the angle I'm looking for is not the angle inside the triangle. The angle I'm looking for is the angle outside the triangle over here. Okay, students? All right, let's continue on. Having said that, let's see if we can't draw our triangle. Okay, so our triangle's right here. Now, I always think it's best to maybe draw the triangle off to the side so you can see it a little better. So I'm going to draw a smaller triangle, okay, like this. Now, we know this height right here is 26,400 feet. Now, students, please look carefully. From here to here is 400. So if I call this from here to here 400, then I better call from here to here 800, because we had said earlier from here to here is 1,200. So we have 400, then 800, then 150. So the real length of this side of the triangle over here is 950. Okay, hopefully you see that. Okay, from here to here is 150. And then from here to here is 800. Okay, students? All right, so I have a side here of 260 and a side here of 150. Here's my right angle. Here's my right triangle. I'm going to call this Y. Now, very quickly, dealing with Y, this is my opposite and this is my adjacent. So I'm going to use tangent, and I'm going to say the tangent the tangent of, I'm going to have to go to another page here, the tangent of y equals opposite over adjacent, so 26,400 over 950. So real quick with my calculator, second tangent of 26,400 divided by 950 will give me 87.93. I'm going to go ahead and put 88 degrees. Okay, it's going to be a little easier. So right here, y is 88 degrees. Okay, now if this is 88 degrees, then that means this little angle right here has to be 2 degrees, because this angle here and this angle here have to add up to 90 degrees. So I did it. The angle of depression would be 2 degrees. Okay, now let me very quickly one more time say this. When we're dealing with angles of depression or elevation, always draw your horizontal line and then draw a line going upward if it's angle of elevation, or draw a line downward like we did here if it's an angle of depression. Okay, and the angle that you're looking for is always formed with the horizontal line and the angle and the line that you drew. Okay, so important that you understand that, students. All right, okay, moving on to number 37. Let's see here. During takeoff, an airplane's angle of ascent is 18 degrees. Speed is 275 feet per second. Find the plane's altitude in after 1 minute. Okay, so here we go. Let me quickly get a picture of this. Here's the runway. The airplane's taking off. Now I know 18 degrees is not this steep, but it kind of helps sometimes to give a bigger angle so that you can see a little better what you're dealing with. So I'm going to call this 18 degrees. Okay, and we're looking for the plane's altitude. So here's the plane right here. We're going to be looking for its altitude right here. We'll call that, I guess, X. And here's the plane right here. Now we're looking for the altitude after 1 minute. Now let's be really careful here. Okay, the speed of the airplane is 275 feet per second. Okay, so it's going that many feet in just 1 second. Okay, now the plane has traveled for 1 minute. So if the plane's traveling 275 feet in a second, to find the distance the plane has traveled from here to here, well, I've got to take 275 times 60 seconds. Okay, and if you do that correctly, you will get 16,500. All right, so in 60 seconds or 1 minute, the plane has traveled how many feet? 16,500. So right here, 16,500 feet from here to here. Okay, now having done that, it's really a simple problem. Now that we've drawn the triangle, I mean, we're looking for the altitude of the plane. Here's my degrees. I'm dealing with opposite and hypotenuse, so I would very quickly say the sine of 18 equals opposite over hypotenuse. Multiply both sides by 16,500. So with my calculator very quickly here, I'm taking 16,500 times the sine of 18, and I'm getting out 5,098.78. So I'm going to put 5,098.8. Now that's feet, of course, students. All right, now I'm looking to see if it told us whether they wanted our answer in miles or feet or whatever. It doesn't say. I'm going to look in the back of the book here. The back of the book has it in feet, so we're totally fine. The back of the book had this for an answer, 5,099, which they just rounded here, and we rounded here, so the same thing. Okay, let me get a drink here. And moving on. I hope this has made sense, students. Again, airplane started here. Here's the runway. It was going down this way. It takes off. Add an ascent of 18 degrees. It traveled this far. Find the altitude after 1 minute. Okay? All right, moving on to number 39. 39 is a pretty simple problem. A sign on the roadway at the top of a mountain indicates for the next 4 miles the grade is 10.5 degrees. Find the change in elevation. Well, students, they've given you everything you need. Here's a triangle. They've drawn the whole thing for you, which was very nice of them. So there we go. So this angle right here is 10.5 degrees. The length of the hypotenuse is 4. And they want you to find the change in elevation. In other words, you were here, which means you were here, and you drove from here to here. So the change in elevation would be this height right here. That's what elevation is, okay? The height. So we're dealing with hypotenuse and opposite. So I'm going to say the sine of 10.5 degrees is opposite over hypotenuse. Multiply both sides by 4. 4 sine of 10.5 degrees equals x. Let me grab my calculator real quick here. And just so you know, students, I am checking these as I go in the back of the book to make sure we're getting them right, make sure I'm not making a little mistake anywhere. So I am doing that. And this is number 39, and the answer is 0.7289. I'm going to go ahead and put 0.73. Now let's stop for a second. Are we dealing with miles, feet, inches? Well, look, 4 miles. So it's 0.73 miles. So when you traveled 4 miles diagonally, you had gone straight up in the air 0.73 miles. Okay? All right, moving on to number 41. Number 41. All right. I think they've done a really good job of giving us a picture of what they're talking about. I am going to go ahead and cut this triangle out and use it. That's pretty good. Okay, I'm going to go ahead and pull this over here. I guess I'll pull it over here. Because students, in a second I'm going to get rid of this picture right here completely, okay? So, all right, here we go. We're going to call this A. This is a right angle. This is C. And this is B. And we'll call this 50 meters. Okay, here we go. Let's read the problem, all right? Here we go. A surveyor wishes to find the distance across a swamp. So from here across, okay? The bearing from A to B is 32 degrees west, and the surveyor walks 50 meters from A and arrives at point C, and at point C the bearing from C to B is north 68 west. Find the bearing from A to C and the distance from A to B. So very quickly here's what I'm going to do. I'm going to go ahead and slide this down here, and I'm going to write the two things we're looking for. We're looking for the bearing from A to C, and then we're looking for the distance from A to B. Alright, so with that in mind, I'm going to go ahead and get rid of this picture now, and we're going to go ahead and get to work, okay? Alright, now, they've given us some bearings, so I'm going to very quickly draw those bearings on here, so please pay attention. Actually, I got to bring that back up again, so I apologize for getting rid of this a little too early. Sorry about that. Let's see here. Okay, we have, and we'll get rid of this picture in just a second, the bearing from A to B. So here's A to B is north, so I'm going to go ahead and draw a north line right here. Here's my north line right here. I'll make it dotted. Here's my north line, okay? 32 degrees west, so I rotate from here to here, and that's 32 degrees. So to make this a little easier to understand, I'm going to go ahead and label this right here 58 degrees, okay, because the whole angle has to be 90, and 32 plus 58 is 90, okay? Now, they also tell us the bearing from C to B, so your C, the bearing from C to B is north 68 west. So I'm going to go ahead and put a point here, and I'm going to go north from the point, So from the point I went north and I rotate 68 degrees, right here, west. All right, there we go. Now let's go ahead and see what we have to do here. First of all, we're looking for, we've got a right triangle here. We've got to find the distance from A to B, okay? And then also find the bearing from A to C. Now students, finding the bearing from A to C is pretty simple to do, to be honest with you. If you'll look right here, we're going from A to C. So the bearing would be, we're going from A to C. So we're going north or we're going south. Well, obviously we're going up, so I know my bearing is going to be north. Then I'll put a blank, and then I went north, and then I rotated east. Do you see that okay? I went up north, and then from this north line right here, I rotated east. So I rotated to the right, which is east. So I'm going to go ahead and put east. And students, from this north line to my line of direction is this angle here. I've already found it's 58 degrees. So there's your bearing, north, 58 degrees east. Okay. Now the distance from A to B. Well, students, I want to take you back to geometry from last year, a couple years, I guess last year. Remember, students, when two parallel lines are cut by a transversal, alternate interior angles are congruent. This angle here is congruent to this angle here. You go from parallel line to transversal, from transversal to parallel line, and those angles will be congruent. So we're going to apply that real quick here to this problem. I'm going to go ahead and make this line here a little longer. There we go. I'm going to make this line a little longer. You got to learn to look for stuff like this, okay, students? And then here's my transversal right here, cutting the two parallel lines. Now, how do I know they're parallel lines? Because this line you went due north, and this line here you went due north, so they're both perfectly vertical lines. Now, watch this carefully, students, please. I'm going to change colors here. Watch. From parallel line to transversal is 58 degrees, and from transversal here to parallel line is 58 degrees. It'd be like this: parallel line, cut by a transversal, like this. This angle here is congruent to this angle here. Now, Mr. Aaron, how does that help us? So I'm going to show you. Okay, watch carefully. I'm going to show you exactly how that helps us. Now, watch carefully. So if this angle here is 58, then this angle here is also 58 degrees. Now, watch. We have a straight line here, and a straight line always is 180 degrees. So if I know from here to here is 68, and from here to here is 58, if I add those two together, I would get 126. 68 plus 58 would be 126. So then take 180 and subtract that, and you're going to get 54 degrees inside your triangle. And that's so important. That's so important. Look what you have now, students. Look, I'm going to draw it over here for you. You've got a right triangle that looks like this. Here's your right angle. Here's B. Here's A. Here's C. And now you know this angle inside the triangle is 54 degrees. And you know this length right here is 50. So we can easily find the distance from A to B. We're going to call this X. We're dealing with opposite and adjacent. So what we have is tangent of 54 degrees equals opposite over adjacent. Multiply both sides by 50. And here we go. 50 times the tangent of 54 degrees. Okay? And if you type that in correctly, you'll get 68.81, which we're going to round to 69, I believe. I'm looking at the back of the book now. They have 68.81 68.82. We're going to go ahead and put 69. Either way is fine. So the distance from A to B would be 69. I think we're dealing with meters. Yes, meters. So there we go. The distance from A to B is 69 meters. And students, don't get hung up on where to round. If I don't tell you where to round in the problem, if the book doesn't tell you, then I'll accept wherever you decide to round. Okay, it's not a big deal. Okay, so pretty tough problem. You had to look for parallel lines and a transversal, but you know, a reasonable problem. Okay, moving on to number 43. Number 43. Okay, here we go. Let's take a look here. Okay, a ship is 45 miles east and 30 miles south of the port. So here's my port right here. I'm going to go east and then south. Okay, that's what it says. So here we go. Here's my port right here. A ship is 45 miles east and then 30 miles south. So here's the ship right here. Okay, I'm going to go ahead and draw a line right here. I'm going to assume I'm going to need that eventually. And it says, if the captain wants to sail directly to the port, what bearing should he take? Now, students, he's here and he wants to go here. Okay, so the bearing, let's call this A, and we'll call this B. He wants to find a bearing from where he is, A, to the port, B. So here we go. Going from A to B is north. So I'm going to go north, which I already have that line drawn. And then I'm not going to rotate to the right, obviously. I'm going to rotate to the left, which would be west. And that's the angle I'm looking for. We'll call it X. So based on this angle here, here's my right angle. Based on angle X, I have opposite and adjacent. So I'm going to use tangent of angle X equals opposite over adjacent. With my calculator, I'm going to hit second tangent, 45 divided by 30, enter, and I'm going to get, for number 43, 56.309, so I'm going to put 56.3. So your bearing would be north, 56.3 degrees west. Okay? All right, let's continue on to number 45. Distance between ships, okay? And I'm not sure if they give you a picture of this. I don't think they do, but let's see if we can figure this out. Okay, here we go. An observer in a lighthouse 350 feet above sea level observes two ships directly offshore. So here's sea level, here's the lighthouse, and the lighthouse is 350 feet above sea level. Okay? All right. He sees two ships, and we'll just say one ship is here, and we'll say we're going to extend this line a little bit so we have a little more space to work with, students, and we'll say the other ship is here. Okay, now the angles of depression to the ships are 4 and 6.5. So here's my first angle of depression right here. Okay, not a very good one. We'll fix it real quick here. And then here's my other line I'm drawing. There we go. Now again, students, it really doesn't matter if your drawing is drawn to scale. That's not super important. I like to make my drawings big enough so I can write angles in and stuff like that, okay? So here's a right angle right here. And now let's see what we have here, students. Okay. Angles of depression. Now remember, you have to draw a horizontal line like this. Not a very good horizontal line. Let's go ahead and use this and make it red There we go. And then we'll lower it down, okay? So here's my horizontal line right here. Now, students, please watch this. You might be saying, well, Mr. Earhart, they didn't tell us which one of these angles is 4 degrees and which one's 6.5. Well, guys, I mean, use common sense. From here to here is the smaller angle. From here to here is the bigger angle, okay? So the smaller angle is going to be 4 degrees. And I know that's not 4 degrees, but again, I've drawn my angles bigger on purpose, students, so I have room to work with my angles. I can draw stuff in here, okay? It's very important that we do that. Now, from here to here is 6.5 degrees, so I'm going to go ahead and just put the smaller angle, and the smaller angle here, excuse me, is 2.5 degrees. So if I take this angle here with 1 dot and this angle here with 2 dots and add those together, I will get 6.5 degrees. Okay, so there's my angles of elevation. Now, they're asking us to find the distance between the ships. So we're trying to find the distance from here, right here, all the way over to here. Okay, now I'm seeing 2 right triangles. Students, watch carefully. I'm seeing a right triangle right here. That's my little one, okay? And I'm finding a big right triangle right here in green here, all the way across to here. Now, I'm not for sure, but I think it'd be helpful if I went ahead and found this angle right here. Now remember, students, this whole angle from here to here is a right angle. So if this is 4 and this is 2.5, the whole angle is 6.5. So I'm going to take 90 degrees real quick, and I'm going to subtract 6.5, and I'm going to get 83.5 for this angle here. Now, if you take this angle here with 1 dot, this angle here with 2 dots, and this angle here with 3 dots, and you add all 3 of those angles together, you will get 90 degrees, okay? All right, moving on. So, with all of that in mind, I really don't need this problem here anymore. I know what I'm looking for. How far are the ships apart? So we're going to move that down here and get us a little room to work with, okay? Let's slide this up here. Now let's go ahead and draw a little triangle and a big triangle. Okay, there's my little triangle, and here's my bigger triangle. Okay, so here we go. This is 350, and this is also 350. All right, this is right, this is right. Now the little triangle is the angle right here, 83.5. Okay, we're going to call the distance from here to here x, so we'll call this x. Now, the other triangle goes from here all the way to here. Okay, so it's 83.5 plus the 2.5, so 83, 85, 86 degrees. And I hope you see that okay, students. The big triangle comes down right here and comes down right here. Okay, so we're not including the 4 degrees. All right, it would be 86 degrees, this angle here plus this angle here. All right, so now we're going to call this whole distance from here all the way across to here y. So y is going to be all the way across, okay? So we'll call this y. Now very quickly, using, let's see here, let's use, this is opposite and adjacent, so tangent of 83.5 equals opposite over adjacent. Multiply both sides by 350, so I have 350 times the tangent of 83.5, and I will get 3071.9, so I'm going to put 3072, so the distance for x is 3072. Alright, now let's find y, the entire length all the way across. So very quickly, the tangent of 86 degrees equals opposite over 350. We'll multiply both sides by 350. 350 times the tangent of 86 degrees would be 5,005.2. I'm going to go ahead and put 5,000. So the whole length all the way across is 5,000. So my goal, students remember, was to find the distance from this ship here to this ship here. So 5,000 minus 3,072 is going to give you approximately, and let me look at something real quick here to see what problem we're in. Problem 45. Let me check it in the back of the book to make sure we're right. Yes, we're correct. If you subtract those two, you will get 1,933, I believe. 1,933.3 is what I'm getting here on my calculator. Okay, so 1,933 feet. And of course, it also depends on where you've been rounding at the whole way through this problem, students. But again, to review, this is a really good problem when it comes to making sure you understand angles of depression, and then also being able to draw your right triangles, and then understanding you're finding a total distance and then subtracting part of that distance to find the remainder distance over here. We'll call that Z. Okay, so there's your distance between the two boats, 1,933. All right, moving on to number 47. Okay, students, here we go. An airplane flying at 600 miles per hour has a bearing of 52 degrees. After flying 1.5 hours, how far north and how far east will the plane have traveled? Well, here we go. Not too difficult to figure out here. Let's go ahead and draw a coordinate plane like we need to do. Okay. And we've learned that when dealing with airplanes, you start on the positive y-axis and you rotate clockwise. So we're going to rotate 52 degrees. So we start here, rotate 52, and so the plane starts here and it takes off this direction here. Okay, so there we go. Put a little point here and we'll put 52 degrees right here. While I'm putting 52 degrees right here, I'm going to go ahead and put 38 degrees here. I may as well. Okay, and let's continue on. Now, the airplane is traveling at 600 miles an hour, and he's doing this for an hour and a half. So his first hour he's going to travel 600 miles, and then for half an hour he'll travel 300 miles. So his total distance he'll travel would be 900 miles. Okay, so this distance is 900 miles from here up to here. Now, the question they're asking very simply is how far north. So the distance from here to here has the plane traveled, and how far east, the distance from here to here. So really pretty simple. We'll call this X, we'll call this Y, and here we go. Sine of 38 degrees equals opposite over hypotenuse. Multiply both sides by 900, and we'll have 900 sine of 38 degrees, which gives you 554.09. So I'm going to go ahead and put 554.1 miles. And students, that's going to be your north. Okay, how far north you traveled. So north, okay. And now let's find the east x. So we would use the cosine of 38 degrees is adjacent over hypotenuse. Multiply both sides by 900. So we would have 900 times the cosine of 38 degrees. And we'll get 709.2. And I'm checking the answers in the back of the book. Yes, 709. So 709.2 miles. And that would be your x. So that would be your east, okay? All right, moving on to number 49. 49 is a pretty tough problem, students, so please take some really good notes and please pay attention, okay? Here we go. A plane is observed approaching your home and you assume the speed is 550 miles an hour. The angle of elevation is 16 degrees at one time, and then 60 seconds later or 1 minute later, the angle of elevation is 57 degrees. Approximate the altitude of the plane. Okay, so here we go. Here's the ground. And the airplane was here. Okay, it was. And we are going to assume the plane flew in a straight horizontal distance, okay? We're going to have to make that assumption. And so it says 60 seconds later or 1 minute later, you looked up and we'll say the plane was here, okay? And you say, well, Mr. Earhart, how did you know the plane was not flying away from you? Well, very simple. Notice your angle of elevation got bigger. Your first angle of elevation was 16 degrees, and your next angle of elevation was 57 degrees. Okay, now I know my angles are not drawn to scale. I get that. That's okay. Again, I want space to draw stuff in here. Okay, so the plane traveled from here to here. All right. Now let's fill in everything we know. All right, here we go. First of all, we know the angle of elevation from here to here is 16 degrees. And then from here to here is 57. So I'm going to go ahead and put 41 degrees right here in this little angle here. And again, I know it's not drawn to scale, and I'm fine with that. Not a big deal. So there we go. Now, what else do we know? You're assuming the speed is 550 miles an hour. How far would it travel in 1 minute? Well, I mean, that's pretty. We got to get a calculator here and figure this out. If it's going to travel 550 miles in 1 hour, that's 60 minutes. Let's divide it by 60 and see how far it travels in 1 minute. Okay, so 550 divided by 60 gives me 9.1666. Repeating, I'm just going to go ahead and put 9.2 to make this a little easier. Okay, so the plane has traveled 9.2 miles. All right, now let's see what we're looking for here. Find the altitude of the airplane. So here's the altitude right here. And that's what we're trying to find. Okay, now if you'll look, this is going to be a little difficult to do, okay, but we're going to try to figure this out. Now, the first thing I want to point out to you is this. There's definitely more than one way to solve this problem, okay, but for me, students, I'm seeing these lines right here of elevation go up from here to here and here to here. So I said to myself, okay, it's probably better if I draw my right triangle like this. This is what I thought, okay? So I said I'm going to draw a right triangle here and over so that I have these angles here to use. So what I saw, students, was a little right triangle from here to here. Okay, there's my little black right triangle, and then a big green right triangle right here. This is a really hard problem, okay? And the reason it's difficult is we're going to have two unknowns. We're going to have to write two equations. Okay, this is probably the hardest problem we're going to do today out of your homework, in my opinion, okay? So remember, you might not have thought to have done this on your own, but please listen, and hopefully you'll learn from this and be able to do this on your own the next time, okay? So here's my little triangle here, okay? And we're going to call this, we're calling this height here x already, so I'm going to bring it over and put x right here. Remember, we're trying to find the altitude of the plane. Now, hopefully you see how the altitude of the plane right here is the same as the altitude over here. They're the exact same height. So if I'm calling this x, I'm going to call this x also. Now, I'm going to call this y. So here's my little triangle. Put a right angle, put an x, put a y. Now, this whole angle, please don't miss this, students, the whole angle is 90 degrees, okay? 90. So, if from here to here is, what, 57, then this little angle right here has to be 33. So I'm going to put 33 degrees right here, all right? Now, here's your big triangle right here. It's right here, okay? Right there. Now, for this side up here, I'm going to put y plus 9.2, correct? From here to here is y, and from here to here is 9.2. Now, the height here, I'm going to put x, right angle. Now, this triangle goes from this line here to this line here, so I need these two angles here, the 41 plus 33, okay? So I'm going to put 74 degrees. Now, I have two unknowns, and hopefully you learned this from Algebra 2. Whenever you have two unknowns, anytime you have two unknowns, you always need two equations. If you have three unknowns, you need three equations, and so on and so forth. So, I have two unknowns. I'm going to have to write two equations. Well, my first equation over here for triangle number 1, we'll call this triangle number 2. And let me pause and say this, don't lose sight, students, of the trees for the forest. Don't forget, we're trying to find the length of x, okay, the altitude of the plane. Alright, so for this triangle here, triangle number 1, I can say tangent of 30 equals opposite over adjacent. There we go. That's an equation that has an x and a y. Now I come over here and I say the tangent of 74 degrees would be opposite, which is y plus 9.2 over adjacent. Now, please watch this carefully, students. Over here, I have an equation with x and y, and over here an equation with x and y. So we're going to have to use substitution to solve these equations for x and y. Really, all that I want to solve for is x anyway. So, in this equation here, I'm going to multiply both sides by x. So if I multiply both sides by x, I'm left with this right here. There we go. Okay, so what does y equal? Y equals x tangent of 30. So over here for y, I can get rid of y. And in place of y, I'm going to put x tangent of 30. Now, if I could just solve this equation for x, I'm home free. And of course, you students probably laugh and say, yeah, that's not going to be too easy. Well, it's not too difficult. First of all, you have a denominator of x, so I want to get rid of my fraction, so I'm going to multiply both sides by x. So if I multiply the left side by x, I get x tangent 74 degrees. If I multiply the right side by x, my denominator would cancel with x. I'm left with x tangent 30 plus 9.2. Now you're solving for x, and so you want to get all of your x's on one side. So this is one whole term right here. That's one term. They're being multiplied, so bring it over. It's a positive x tangent of 30. And actually, this should be 33, shouldn't it? So 33, I believe. Let's go back a page and look. Should it be 33? Did I get this wrong? Let's really make sure we're doing this right. Hold on one second, students. Yeah, I apologize. So hopefully in your notes you have 33. Sorry about that. So 33, and this would be 33. So the substitution here would be 33. Sorry about that, students. This would be 33. Okay? All right, now moving on. So bring this over, and you have x tangent 74 minus x tangent 30 equals 9 point. I think that's also supposed to be 9.2. 9.2. Now, students, you're solving for x. You really should know how to do this. Factor out an x. So factor out your x, and you're left with 74 degrees. Tangent 74 degrees minus tangent of 33 degrees. I don't know why I'm just so dead set on using 30. Okay? Now look what you did. You pulled an x out of both terms. So now if I want to get x by itself, all that I do is mess everything up like I just did. Sorry about that. All that I do is I take that and I divide both sides by tangent 74 minus the tangent of 33. Alright? So if I divide one side, I've got to divide the other side by the same thing. There we go. Now these would cancel, and so you're left with x equals 9.2 divided by tangent of 74 minus tangent of 33. Now students, I want to warn you, when you type this into your graphing calculator, be really careful, okay? Because I made this mistake the first time I did it, so watch carefully. You'll want to type into your calculator 9.2, then divide it by, then when you hit parentheses, first of all, students, hit parentheses, because you're going to put two terms in your denominator, so be sure and hit parentheses. So 9.2 divided by, then hit parentheses, then hit tangent. Now when you hit tangent, this automatically pops up with another parenthesis. So when you put in 74, be sure and close the parentheses. If you don't, you will miss the problem. Then hit minus, hit tangent. Of course, this parentheses will pop up right here. Put 33, and then close the parentheses, and then close it again. So hit parentheses twice. Now, if you'll hit enter on that, you will get the correct answer. I've already checked all this out, and the correct answer for number 49 is 3.23 miles. Now, I don't know 3.23 miles, and we were in miles. Don't forget that back here in the problem, we found out how many miles it traveled, and it was 9.2 miles. Okay, so I don't think the original problem said what unit of measure to use. No, it does not say, and that's actually the incorrect problem. But number 49 in the book did not say whether it wanted miles or feet, so we're going to leave it miles. And so there you go. This would be 3.23 miles was the altitude of the plane, how high up it was. Okay. So students, that's it. I hope this video has been a help to you. Sorry that my voice has been so bad, but hopefully you can hear everything okay. Contact me, call or email if you guys have any questions, okay?